7th grade. Happy Tuesday. Okay, so I thought that beluga was super cute. So today we're going to continue to review volume and surface area of solids. Tomorrow you will be given a Chapter 8 assessment, and feel free to spread it out throughout the week, and it's open book, okay? So use whatever resources you would like to help you answer the questions. It's a pretty long test, so I would recommend just doing a little bit on Wednesday, and then doing a little bit on Thursday, and then doing a little bit on Friday, okay? And come to me with questions on Thursday during our go-to-meeting session. All right, so just as a reminder, in your textbook, there is this really handy chart at the end of Chapter 8, so don't forget to refer back to it, especially when you're taking your open book Chapter 8 assessment. All right, so we're gonna continue and do what we didn't get to complete, which was the 8.5 numbers 1 through 9 odds, okay? And so I'm just gonna kind of go through the problems, but what I want you to do is, as I go through the problems, I want you to have like a piece of paper ready, and I want you to also do the problems, like pause the video and just try it out on your own, okay? And then see if your process was similar to my process, okay? And that's how you can kind of learn and prepare for the assessment tomorrow, okay? All right, so I'm not gonna read it out loud. I'm gonna assume that you're pausing the video and you've already read it, okay? All right, so in this case here, Jack has those 8 cylinders, and we want to try to find the volume of those 8 cylinders. I recall that the volume of a cylinder is pi r squared times the height, okay? And they give you the radius as 0.6, and they give you the height as 22 centimeters, okay? So what I'm going to do is, I know that there's 8 cylinders, okay? So I'm going to multiply 8 times this pi r squared times h, okay? And again, they give you r as 0.6, and then they give you h as 22, okay? And if you input this in your calculator and you simplify, except for pi, okay, you should get 63.36 pi. And then the directions in your book say to use 3.14 as an approximation for pi. And because we're approximating it, because pi is an irrational number, right? It's like, and so we're just kind of approximating it to 3.14. Okay, it's not the actual exact value of pi here. So we're going to put this little squiggly line of an equal sign, which means approximately equal to, and we're going to round it to the nearest tenth, which should be 199.0 cubic centimeters. Okay. All right, and for question 3, okay, so we have a necklace with 50 spherical beads, okay, and so I recall that the volume of a sphere is 4/3 pi r cubed, but we have 50 of them, okay, so if we have 50 of them, I'm going to do 50 times 4/3 pi r cubed, okay. And they give you the radius, don't they? Right? It has a radius of 8 millimeters. Okay, so I'm going to input in 8. Okay, And if you input everything in your calculator and use 3.14 as an approximation for pi, this should become, and remember we're rounding it to the nearest tenth. Okay. All right, so part B asks you to find the surface area of the necklace. Okay, and so I recall that the surface area of a sphere is 4 pi r squared. Okay, and how many beads are there again? There's 50. Okay, so what we're going to do is we're going to do 50 times surface area of one sphere. Okay, that'll give us the surface area of the 50 spheres, spherical beads. Okay, so 50 times 4 pi r squared, and again r is 8 millimeters. Okay, 50 times 4 pi times 8 squared. Okay, and if you input everything in your calculator with 3.14 as an approximation for pi, okay, you should get 40,192 cubic millimeters. Is that what you got? Good job. All right. Let's go to the next one. Okay, so now in this problem, okay, this problem I was getting a bit tripped up by the wording of it. I don't know if that's how, you're feeling or that's how it's going for you. Now, let's look at the last sentence. It says, what is the volume of the cone of the slush? So originally, I was just thinking, what's inside the cone, not including that hemisphere of the slush. But that question is talking about the whole slushy cone, including the cone part at the bottom and the hemisphere of slush. Okay, so that's what it means. So in number 5, do they give you r, the radius? It looks like they give you the diameter, right? And how do I find the radius from the diameter? Well, I just need to divide it by 2, right? So the diameter is 8. I'm going to divide it by 2, and that becomes 4 centimeters as the radius. Okay, so now that we have this, I recall that the volume of a cone is 1/3 times pi r squared h. Okay, but it's not just the volume of the cone that I'm finding, right? I'm also trying to find the volume of the hemisphere. But for me to get the volume of the hemisphere, I have to first think about the volume of a sphere, right? So the volume of a sphere is 4/3 pi r cubed, but a hemisphere is half of a sphere, right? So when we want to do half, so the volume of a hemisphere is equal to half times 4/3 pi r cubed, okay? And then once we figure the volume of the cone out and the volume of the hemisphere out, this is actually a composite solid. And so we're going to add the volume of the cone and the volume of the sphere together, okay? So let's just go back to here, the volume of the cone. Okay, we're going to input in the values of what we were given, okay? So it's 1/3 times pi, and then r was 4 squared times, and what is the height? It's 10.8 centimeters, okay? And then this, if you, what I would like for you to do, because we're going to later on add the volume of the cone to the volume of the sphere, I don't want you to approximate this right now. I want us to get the exact value the exact measurement of the volume of the cone. And to get it exact with the irrational number, we have to keep the irrational number as an irrational number. Okay, so we're going to leave pi as it is. So if you simplify this as much as you can, this will become 57.6 pi cubic centimeters. Okay, so here, okay, let's input in our values for, and then our values for the volume of the hemisphere. Now R is 4 cubed. And again, same thing here. We're not going to approximate this yet. We're going to approximate it later, okay? And I'm going to show you why, okay? And so hang tight with that, all right? So this, I'm going to simplify it as much as I can, and I'm going to keep pi because I want an exact answer, an exact value for the volume of the hemisphere, okay? You're going to get 42 2/3 pi cubic centimeters, okay, equals, all right? Okay. And now to find the volume of the cone, okay, the volume of the cone, of the slushy cone, or I'll just say slush. Did they say slush or slushy? Slush. You have to take the volume of the cone plus the volume of the hemisphere, okay? And so we're going to input in our values here, our exact values that we got, plus 42 2/3 pi, okay? And do you guys remember how we combined this together? Okay, so we're going to do 57.6 plus 42 2/3 in the parentheses, and then we're going to multiply that by pi, okay? And if you now input this in into the calculator, okay, this will become 314.8 cubic centimeters, okay, approximately. All right. Now you might be wondering, well, why couldn't I approximate it later or earlier, right? So let me show you. Okay, so let's say for this value here, you want to approximate here for pi as 3.14. So then if you round it to the nearest tenth, this becomes 180.9. Okay, and then here, if you want to approximate this if you want to approximate pi as 3.14 and put it in right away and you round it to the nearest tenth, it becomes 134.0, okay? So then here, if you add 180.9 plus 134.0, this actually becomes 314.9 cubic centimeters rounded to the nearest tenth. And you see that it's a little bit off, right? It's about 1/10 off, okay? So it's really important when we want to get as close to the exact answer as possible that we approximate for pi. We save it as the last step, all right, as you can see here, okay? All right, so we're going to move on to the next one. Okay, so for that one, okay, it's a composite solid, isn't it? Because there's two solids that we have to account for, okay? And we're finding the volume, not the surface area of that pyramid. It's a square pyramid. And so I remember that the volume of a pyramid is 1/3 times the base times the height. Now in this case, the base is it a square or a rectangle? From the information that was given, it says that it's a square, right? So how do I find the base Well, to find the base, I have to do e squared. Okay, to find the area of the base is e squared. All right. So here, okay, this will be 1/3 times e, which is the edge of the base, squared times the height. Okay, and that's the volume of the pyramid. But how many pyramids are there? Oh, there's 2 pyramids, right? Okay, so you want to do 2 times this. So 2 times 1/3 times e squared times h. And they give you a value for e, don't they? The edge is 11. So 11 squared times, and then the, let me see, the height is, did they give you the height? Oh, it tells you in the information is 14. Okay, and then if you input this in the calculator, this will become 1,129 1/3 cubic inches. Okay, or if you want to round this to the nearest tenth, it'll be 1,129.3 cubic inches. All right. Oh. Okay. So now, just trying to find where I put some of my. Okay, here it is. Let's go to the last problem. Okay. Gosh, I gotta make my video screen a bit smaller. Okay. So in here it says, so we see a cylinder, and how many cylinders do you see? There are 3, right, that are attached together, and each pole has the same diameter of 18 centimeters. Okay, so if the diameter is 18 centimeters, then how big is the radius? Again, you have to do diameter divided by 2, which is equal to 9 centimeters. This is the radius. Okay. All right. So let's look at part A. It says we want to find the volume of the pole. Okay. And so here, what I would recommend doing is actually this. Okay. So there's 2 ways that you can do it. Okay, you can do the volume of the first cylinder plus the volume of the second cylinder plus the volume of the third cylinder. Okay, or right, what you can do is you can just add the height of the first cylinder with the height of the second cylinder with the height of the third cylinder. And then you can get the height of the total cylinder, okay, as opposed to doing parts of the smaller cylinders, okay? So it might save you a step or 2, okay? So here, let's say now that's a new cylinder made out of those 3 cylinders, okay? And again, the diameter is the same, which means the radius is the same, okay? So in this case here, then we have, I wanted to use purple, okay? We've got pi times, and what is r? R is 9 squared. And what is the height? Well, the height is 7 plus 11 plus 15 centimeters, right? And that'll become 33 centimeters. Pi times 9 squared times 33, and 9 squared is 81. Okay, and then this will become 2,673 pi, but we're going to use an approximation for pi as 3.14, so then this will become approximately 8,393.2 cubic centimeters. Okay, and again, remember we're rounding to the nearest tenth. That was given in the directions to do it when we approximate 3.14 for pi as pi. Okay. All right. And now the last part. Yay! We're nearing the end. Okay, part B. So here, they want us to find the surface area, okay, of the cylinder. Okay. Now again, you can do the surface area of the shortest cylinder plus the surface area of the mid-sized cylinder plus the surface area of the large cylinder. But again, because the diameter is the same for all three cylinders, which means their radius is the same for all three cylinders and it's connected, what you could do is you can just you can kind of do what we did before in part A, where we just treat it as like one larger cylinder. Do you see that? Okay. So let's see. So I recall that the surface area of a cylinder is 2 pi RH plus 2 pi r squared. Okay, can you see the squared here? Okay. And so I'm going to input in my values of what I know. So 2 pi, and then r is 9, and then the height is 33, right? Plus 2 pi, and then r is 9 squared. All right. And then this will become okay, if you simplify, this will become 594 pi for this value here, okay, plus 162 pi, right, which will become 756 pi, okay, and then now we can input in 3.14 as an approximation for pi, and then this will be approximately equal to 2,373.8 cubic centimeters. Okay. Good job. Thank you for sticking through. I'm trying to how do I make my thing smaller? I don't know if I can make it smaller? It's gonna stop. Okay, I might disappear after this. Oh. All right, so that's all for today, and I will see you on Thursday. Okay, have a good one. Have a good day. All right, take it slow with your Chapter 8 assessment, and remember it's open book, okay? And come to me on Thursday with questions, and we'll try to help you gain a deeper understanding of everything in Chapter 8. All right, bye.